Hey guys, it's David from 3D Make It. Today we're going to be talking Direct Drive Extruder. Let's go. So today we're going to be talking cheap Direct Drive. And when I say cheap, I mean under $20 you can install Direct Drive onto a V-slot roller printer. V-slot roller printers are in the category of Ender 3, Cr10, anything that has those three wheels that move back and forth on that V-slot roller. So we're going to break the video down into what is Direct Drive, how it can benefit you, and then the install towards the end. So I'll be throwing chapters and timestamps in the description just so that it's a little easier to follow and you can get exactly what you want out of the video and what you need. So to start with, let's talk what is Direct Drive and what is Bowden Drive for that matter. So let's jump to my favorite new tool, the pen and the notepad. So on our printers right now, we have a system where there's two gears that push filament through a long tube. And this tube goes down into the hot end. So this tube is a Bowden system. So if we draw our little hot end here, it kind of looks like a Creality hot end, sort of, right? Now, this is a Bowden system. So this tube can cause pressure of the filament as it goes through the system and the extruder moves back and forth. It can kink the tube in different sections. So this Bowden system is good because this is reliable and light. However, aside from that, the Bowden system can cause issues with printing flexible filament as well as printing PETG. Anything that has a little bit less of a grip through this tube and has a tendency to slip at the gear can be an issue. This can cause things like stringing or over and under extrusion just by the way the pressure in the tube is working at the time. Now, normally our filament is 1.75 millimeters. So traveling through the Bowden tube, usually Bowden tubes have a clearance of about 2 millimeters on the inside. So if you get a Bowden tube that's a normal white stock Bowden tube, the inner diameter could be up to 2.2 millimeters, which means there's quite a lot of room in that Bowden tube for the filament to move around. Now, there are other tubes available. I'm not saying Capricorn is the answer, but I like Capricorn. I do use it all the time. And there's two different flavors. There's a TL and an XS. Now, the TL is the light blue, and it has a higher tolerance. So it does have that 2.2 millimeter in there tolerance, whereas the XS tube, which I like to use, is also 1.9. So the tolerance is even closer to the Bowden and the filament. So going through that tube can cause pressure and lead to clicking extruders. Also, the retraction settings needed in a Bowden tube are bigger, which means stringing is harder to control. So the next system we'll talk about is Direct Drive. Now, Direct Drive is similar, but the gears and the extruder sit almost on top of the hot end. So in this case, the filament comes through here through a small piece of Bowden tube. So the length is much shorter and causes less pressure coming down to our hot end. Now, when it comes down to the hot end through this short path, we have less of a problem now pushing filament and even flexible filaments through this little path. The more constrained the extruder gears can be in this path, the better the extrusion is. Now, this setup, as you would imagine, is a bit heavier on the X gantry. So before we were talking Bowden and it was lightweight, whereas this Direct Drive setup is a little bit heavier. Now, when you think about all the advantages to Direct Drive, so we can print flexible filaments. We can print filaments that are a little softer, PETG, nylon, easier. Our retraction settings are a lot less. Through a Bowden tube, you could use up to 4 to 8 millimeters, depending on the length of the Bowden tube, of retraction and a high speed. To get that filament out of the path and back into the path, you're talking a retraction and it's pulling and it's pushing back in. So that's where we can get stringing. When the Direct Drive is working, its retraction works at 1 millimeter instead of that larger distance. So it can do a lot better job with stringing, and the fact that it's not playing a yo-yo game with your filament means that there's less chance of bunching up, so it does print flexibles better. So we talked a little bit about weight, and I just want to be clear. There is more weight when you move the extruder motor from the gantry position on the side to the hot end. So you're shifting the weight, which actually means that the z-axis can actually raise and lower, and it's still moving the same amount of weight. The change is in the inertia of the X gantry. So the jerk and acceleration can get you. However, let's talk real. Most of us print 80 millimeters per second. If you've really tuned in your printer, you can print fast. I've had enders printing up to 160 millimeters per second really, really nicely. Most of my prints, if I want them to turn out really, really nice, so I'm printing a model to finish or give to somebody, I'm printing 60 millimeters a second. And if I want it done quick, I use the old slicer trick, raise the layer height, and then print at 80 millimeters a second. That weight on the gantry doesn't make enough difference to actually cause any issues. So let's play a game. Which one is which? Which one of these models came from a direct drive? And which one of these models came from a Bowden tube? You can clearly see a difference in the models, not only because obviously one is red and one is gray, but there are some minor differences. And I'll point them out to you and I'll circle them in the video. But one is the red guy's leg. If we look at his leg, we can see that there's a bit of weirdness happening. We've got some flaking on his leg here, and that is a retraction issue. On the guy on the right hand side, I'm not saying he's perfect either. There's a bit of the same retraction issue up on his pant leg on the right, but not as much shown. There's a tiny, tiny wisp of a string off of the ball on the one on the right. Now, I'm going to give away the biggest hint. Both of these went through a lighter treatment. So I did burn off some of the stringing. So which one, though, based off of not stringing, because we know that's a dead giveaway, is a direct drive or a Bowden print? Well, here's your answers. This guy came off of a Bowden printer. So when you look at his leg, that's a key sign of retraction quickly. Now, the other thing that he did have a lot of, so if I hold him up nice and close, you can see remnants of stringing where I didn't get it all burnt off. And then he actually has some stuck in his arm here too. So, and you can see here up on this arm, just a little bit of bubbling and stringing. So this one was definitely a Bowden printer print. And here's the gray guy. Now, it's important to note that even though that one is silk red and one is gray, they're actually the same brand of filament, but the silk one does have more elastomer, which means that it is more prone to actually string. So this print turned out fairly well off of the direct drive. The only noticeable strings are on the ball, this ball here, and the cleanup was literally nothing. This is the way this one came off the printer. Now, it's of note that I've put PETG, I have put TPU, and obviously PLA through my direct drive setup. And I've had really, really good results using this system that I'm about to show you. Now, the exact plate and kit I got were from Amazon, so let me just show you which one that is. So this is the kit I did purchase. Now, it was about $15 after Christmas there, so obviously its price has changed a bit, but the components are the same. So when you're looking at this kit, it did come with all of the things shown here. I didn't use some of them, and I'll explain why in a second. But this kit here replaces the back bracket, and the rollers that you have go onto it. It comes with this cable for your extruder. It's of note that the cables that come in these kits are not extensions, so you do have to go to the control box, run your cable out and up and over. There was enough space on it to do this, however it was tight, so the cable they include to extend or switch out, whatever you want to call it, is a little short, and I ended up just using some meter long ones I had on hand, but I'll show that as we go through. It comes with Bowden tube, which is great, but I didn't use that either because I used my cap tube. So This kit is what we're looking at. And here are some comparable ones. So for $19 still, you can get these kits, and you can see they're all the same. They're different suppliers, but they're all from the same parts. So you get the cable, the Bowden tube, the 2 spacer nuts, some screws, and a PTFE coupler. So that's kind of the end of the explanation portion of the video. We're going to show you the install, which is really quite easy. It took about 15 minutes to actually put it all together, but I'll go through the steps that we took. We'll probably speed them up a bit in places just because you don't need to see me trying to work a screwdriver and dropping screws over and over and over. So without any more waiting, here is the install, and we'll catch you after. So first step is disassemble the hot end. Take off the Bowden tube from both ends, hot end and extruder. Remove the blue collets if you have them. Then take the screws out of the housing fan, and last, unmount the hot end from the gantry plate. Loosen the X gantry belt, then take it off from the drive plate. Using the adjustable spanner and screwdriver, loosen the V rollers until it comes off of the gantry. Next, it's time for the extruder. Start by unplugging the motor. Then, undo the screw on the lever arm, being careful not to lose anything floating around like springs or idler gears. Save all the pieces because we'll need to put them back on when we reassemble the extruder. It's time to move the V-wheels to their new home. Take note of the order that the V-wheel is attached to the old plate, which is nut, V-wheel, spacer, and then the bolt goes through from the opposite side. For the one with the eccentric nut, the order is reversed with a washer after the nut. Wait to tighten up the V-wheels until it's back on the frame. Once the assembly is tightened up, you can put the belt back and then check your eccentric spacers to make sure they're at the correct tightness. Next, it's time to tip the ender over, take the bottom plate off the control box, and get that new extruder cable run. Start by installing your hot end. Then put the Bowden tube back into the hot end and put the collar lock on if you choose. Next, you'll do a test fitting of the new extruder on the motor mount. This will require the longer screws, and make sure you use the screws that came in the kit. Once everything is test fit, you can cut your Bowden tube to length, push the new extruder down on the Bowden tube on the top, and then screw everything in nice and tight on that new drive plate. last step is putting that fan shroud back on and then plugging in your extruder. So that was fairly easy. The only real thing to know about this system is when you're using your extruder, you can use the one that came with your printer. You can use the red, silver, or black extruders. They're all upgraded versions of the Creality extruder. They're the aluminum ones, but make sure it's the single geared one, not the one with the 2 gears, the Bondtech-ish gears. They won't fit, it won't work. It's noteworthy that this system removes the issue of the PTFE2 slipping from the coupler, causing filament just to spurt out all over the place. It's a mess. This system stops that because the extruder sits on top of that Bowden tube, and the hot end sandwiches it in, and there's nowhere for it to go. So here's just some final thoughts to leave you with. Would we recommend it? Yes. Now, Greg has another kit, the Mod X, and he's going to do another video on that, which will be great, I'm sure. But would I recommend this one? For sure. Under $20, it works very, very well. Would I put it on every printer, every Ender 3 I have, or every Cr10? No. I will keep some of them Bowden and convert maybe one more to Direct Drive. And that's simply because Bowden can do things Direct Drive can't. And Direct Drive does so many things more that Bowden can do. But I do like a Bowden system for the speed. So I will keep my Cr10 probably Bowden because I can put a giant nozzle on it, tell it to go fast, and hey, we're printing big parts really, really quick. As they say, parting is such sweet sorrow. Thanks for joining me. I hope you found something interesting in the video. Remember, like, share, and subscribe. Also, did you know we have a Patreon? The link's at the end of the video or in the description. You guys are awesome. Thanks again and have a good one.